There is no escaping our next topic, PFAS. In 2019, it became a critical issue for the water industry. Next, we'll hear from the experts who are researching, designing, and constructing PFAS treatment in Orange County. Please welcome to the stage Orange County Water District's Executive Director of Water Quality and Technical Resources, Jason Dadakis, and he will introduce the panel. Jason?
We've been hearing a lot lately about PFAS and PFAS chemicals in the environment, but what exactly are they? They're a group of man-made chemicals that were manufactured starting in the 1940s. They were produced all across the world, production facilities, and firefighting foam that's used at local fire departments, airports, and military bases. Pizza from a pizza box, popcorn from a microwavable popcorn bag, or worn waterproof clothes like a raincoat, you've likely been exposed to PFAS. The EPA says there are more than 4,000 different PFAS chemicals. Long story short, it can be found everywhere.
Good morning, everyone. As many of you are aware, PFAS is a significant issue, water quality issue here in Orange County. Today, we'll touch on some of the related public policy issues, the billion-dollar solution being employed here in Orange County, and then speak with some of the prominent leaders in the PFAS treatment industry. So as that introductory video just showed us, PFAS have become almost ubiquitous in our everyday lives. They have many useful properties, such as water resilience, stain resistance, and non-stick characteristics, and are very resilient and difficult to break down or destroy. Because of their widespread use in industry and consumer products, they eventually end up in landfills or being disposed down the drain, ultimately end up in our sewage, our waterways, and in the broader environment, affecting downstream water users and communities. As shown in the map displayed on the screen here, more than 60 out of our 20 major water supply wells here in Orange County have been taken out of service due to PFAS. This has caused a temporary increased reliance on imported water, which costs our retail water entities approximately twice compared to the price of groundwater. The Orange County Water District is in the process of spending in excess of $250 million to design and construct treatment systems that effectively remove PFAS and to allow these wells to come back online, with total response estimated to exceed $1 billion. Both the state and federal governments are in the process of a multi-year effort to establish enforceable drinking water standards for PFAS compounds. The state of California recently proposed a draft drinking water public health goal for compound PFOA at 7 picograms per liter and 1 nanogram per liter for the compound PFOS, based on a chronic exposure of these compounds at the equivalent of consuming 2 liters of water per day. And once finalized, these public health goals will be the starting point for the state's Division of Drinking Water to establish enforceable maximum contaminant level regulations for these compounds, and this process is anticipated to take up to 2 years. And so that is our backdrop. We're going to have a great panel discussion with some folks who are on the front lines of helping water utilities here in Orange County and around the country manage PFAS and restore their contaminated water supplies. And so I'd like to introduce Patricia Tinnerino with Evoqua Water Solutions, Water Technologies, Dr. Scott Grieco, with Global Technology Leader with Jacobs, and then Kirk Harns, the owner of Pacific Hydrotech. So, opening question for all three of you, and maybe starting with Kirk. Just how many PFAS projects would you say you're working on, and how busy is this type of work keeping your firm right now?
It's really exploded this last year. We actually have 7 projects under contract presently. It will be about 20% of our revenue for this year. One project has 22 vessels on it, and another project has 3 different sites with multiple vessels on each project.
Patricia?
I'd say for Southern California, it probably is consuming 60 to 80% of my weekly workload, and we're at the point now where we're constructing, we're getting these projects online. So I'm out in the field a bit more, getting things going, getting operators trained. So yeah, 60 to 80% of my time at this point.
And Scott?
For me, personally, about 100% of my time. But, you know, as a company, we've been involved for the last 10 years, even though PFAS in the water industry has been really in the forefront the last 2 or 3. So we spent a lot of time doing investigation, really understanding the science, as well as doing things now like in the water treatment side, you know, with actual application.
Patricia, for the benefit of our audience, could you explain kind of the difference between, let's say, what's known as a bench scale test and as compared to a pilot scale test that a utility might use to evaluate their treatment options?
So bench scale test is sometimes referred to as rapid scale column test, or RSSCT. And what it is it's done in a laboratory. The media is typically pulverized or altered, and the fluid dynamics are accelerated. So you get results within days of how well 2 products might perform against each other. A pilot is more real time. You usually do it in the field. You're pumping a slipstream off of an active well. You might be running at double speed, but you're not running much faster than that. So results can take a year or 2 to show up. But it does tend to be a bit more accurate when determining life cycle of a product. Bench scale is very good at comparing 2 products and showing you which one will perform better or last longer. Pilot scale is really good for determining bed life or breakthrough curves. Both can be used for permitting, and you probably have a bit more experience with that.
Yeah, so I mean, the way I look at it, Jason, is that there's really, as Patricia said, there's 2 reasons to do it. One would be to get permitting approval process. The other is primarily around operating cost and certainty of operating cost. So as the regulatory body has evolved in really understanding more of how these treatment processes work, in my experience, it's really become a bit more of the owner's information, less than the regulatory need to really run these tests to select the best media, whether it be resin or carbon or the type of media, in order to get a better projection of life cycle cost. Because that's really driving, you know, the project in terms of the overall value. Is these systems are going to be operating for the long term, so selection of the best performing media for the lowest operating cost is clearly the game. So our personal recommendation, or my personal recommendation, would be that we can get a lot of that information off of the RSSCT tests or the bench scale tests, but there's definitely more certainty and more accuracy if you can do a pilot test.
And if Scott, if utility determines they just don't have time to do the testing, right? They need to implement a solution very quickly. What impact does that have on the design and even the permitting if you don't have the time to gather that information ahead of that?
Yeah, that kind of goes into the evolution of the regulatory process. I can say in other states outside of California, media are already pre-approved, and in those cases, the systems are generally hydraulically designed. So if you know your flow rate, you can design your system. And in that case, you can select a resin or select a system for several different resins and really move forward with the design without having the resin selected immediately. In California, I think that is becoming a little bit better understood. We've gone from requiring pilots to potentially just requiring bench scales, and I think as more and more of these systems are implemented, the need to see the data before approving a system for design, I think is going to be less of a concern than it was at the initial phase.
Kirk, in your role as really overseeing construction of a lot of these projects, we've recently seen and all hearing about steel price increases affecting all types of construction, and product delivery delays on a range of necessary equipment and raw materials. What would you say your firm is finding to be the biggest challenge to meeting construction scheduled deadlines?
I think everyone knows that the supply chain is just really messed up right now. We'll get quotes at bid time for valves at 18 weeks, and they take 46 weeks instead. And trying to get, coming off COVID, getting submittals and all the paperwork side has just been very difficult. And of course, if anything has a chip in it, that is just exacerbated by that. So that's probably the biggest problem we've had. We've also had issues because everyone's so busy in the utilities on projects getting utility plans approved and getting them out to power up and just get us approved. So that's one side. And then the last side, I would say labor. We all hear how shortage of labor is, and getting skilled craftsmen out there to do the work as things grow. We've been lucky because we've grown organically over the years, and we haven't had to do a large-scale hire up. And so we've been very lucky in that, but I know that is a big problem in the industry of having enough labor to get the work done.
Just as a follow-up, Patricia, at Evoqua, are you folks having challenges with raw materials or equipment availability for your systems?
Where we're seeing the biggest impact right now is steel prices and the fluctuation in steel costs. So fortunately for a lot of the projects, we started procuring materials and buying back in 2019. We kind of foresaw what was happening, and we started purchasing bulk and storing it. That is ended up being very good plan, but now for some of the projects that are just coming out, the volatility of steel is making it really tough to quote a firm price. Freight costs have tripled, so getting equipment to the site from the time it's quoted to a year later when it's getting delivered, or 8 months later, so that's been a challenge. As far as resin supply and equipment, all of it's manufactured in the U.S., so we're fortunate that we're not having issues with getting a lot of stuff in from the port. Thank goodness. There are still some things that get delayed, but overall, it hasn't been too bad. I would say just material cost volatility has been the biggest challenge.
Scott, we're hearing the term novel or alternative sorbent sort of being used more and more in the industry now as more of these kind of sorption-based treatment systems and vessel-based systems are being deployed. Could you explain for folks how these alternatives are maybe different than the more conventional sorbent products that have been used historically?
Yeah, so what we're using right now, granular activated carbon, that's a very generic product. It's used for absorbing a lot of things, different contaminants. It's not very selective. Ion exchange is a designed product. It's manufactured. But again, the same products that we're using for PFAS we can use for perchlorate. So again, not very selective. Some of the new products that are coming out, they're being tailored to be more selective towards PFAS, more selective towards the shorter chain PFAS that might be a little bit more difficult to treat, or maybe not difficult to treat, but might require GAC or ion exchange to be changed out more frequently. So that's one aspect with these novel products, that they're being tailored for specificity to treat the PFAS and avoid or eliminate some of the competition with other background water quality. There's a variety of products coming out on the market right now, which are very encouraging from a PFAS treatment standpoint, where some of them are being produced in full production and are certified for drinking water. Others are in more of a developmental stage, but to me it's very encouraging because right now we've been basically focused on using the same products we've been using for the last 20 or 30 years with a new compound that's presenting, quite frankly, some challenges for treatment. I think it's really spurring some innovation in the industry to come up with some new products.
And Scott, is it that selectivity that you talked about that sort of offers the potential maybe cost advantage of these products? Is that what does that lead to? Does that lead to longer life, or how does that play out?
Yeah, definitely in some of the one particular novel product that we've tested, extensively at Orange County, it does have a cost competitive point. So if you add cost competitiveness with the longevity that it shows, it tends to not only be more attractive from a technical standpoint, but it definitely looks to have cost advantages to the producers and to the end users.
Patricia, how would you kind of characterize the current and what do you see as sort of the future availability of these types of alternative sorbents as they come in the marketplace, and the role of a firm like Evoqua in terms of making those available?
Sure. So we're continually looking at new products. One of the ways we found that one of our ion exchange resins works so well is 10 years ago we decided, hey, it's being used in this application, let's pull a strip stream and see what it does for PFAS and other perfluorinated compounds. So we have a whole bank of other products that we've been testing. A lot of them come from other industries where they weren't previously used for drinking water. And we're saying, hey, can we use them now here? And how do they do with the short chains? How do they do for selectivity? So yeah, we're continually looking. As far as supply, I don't think it's an issue right now. Like I said, they've been in practice for the industrial sector, so now it's kind of bringing technologies over. We're also working to improve the resins we have to get increased throughput. And our goal is, once you build these plants, your biggest expense is the ongoing cost to change out this media. If we can get it to last 10% longer, that's going to save you 10%, in your dollars. So we're always looking for that next thing that's going to be the best value, the best removal. As regulations change, I think limits are going to either lower or they're going to want to track additional compounds. So we need to find the solution that's going to provide the best value to the end user and to the producers.
Kirk, do contracts that you bid on and eventually take on that contain maybe some Buy America requirements, do those present any unique challenges to you in terms of executing these projects?
Well, it has. Typically, if you had Buy American on a project and say it was a 12-month project, it'd probably add 2 months to your project, just to source the materials and to get them in. Probably today it would probably add 4 months to your project, just because of supply chain issues. Also, it just has gotten worse. So I guess what I would say there is most of the projects we've worked on so far, they're using alternate water and having to pay for that alternate water at a lot higher expense. So when they're doing their cost analysis of should they go after that funding, it would seem to me that you'd also want to say, okay, what's the schedule impact of Buy American, and is the time period that adds to your project offset enough by Buy American, by that funding source, to make it worthwhile? And so I think that's a piece that really needs to get looked at even more now than in normal times, and because of having to purchase the water from an alternate source.
That's good. Question for, I guess for Patricia. So we talk about how a lot of these, how these media work. They're sorptive. As you allude to, eventually they reach their capacity. And at that point, we have to look into what our disposal options are. Could you tell us how you and your firm are approaching sort of looking in the future about needing to dispose of spent resin or spent carbon for projects that you're servicing in California? What are the approaches you think that you folks will be using?
All right, so as a generator, you are always responsible for your waste. At the end of the day, you own it. So our goal as a service is to limit your liability, right? So I'm going to advise you on what your options are. And right now those options are landfill. Just basically means taking it from one place, putting it somewhere else. Your other option for resin would be, or ion exchange media, would be incineration. And for carbon, you can do reactivation. And there's a couple options with carbon. You can do react and return following NSF protocols. So you reactivate it, and then you get your carbon back with a little bit of virgin makeup because there's some attrition during that process. So you're basically recycling it and taking it back. Or you can reactivate it. It goes to a pool and is later used for, the reactivated product is used for industrial applications or wastewater, some other non-drinking water site. So with the incineration and reactivation, the goal is to burn off or obliterate the PFAS compounds. There are treatments on the stacks of these kilns and these furnaces that further treat the off-gas. There's lots of research being done now on once you incinerate it, what does it break down to? What is the long-term impact? These stacks that release to the air, what are we doing to the air? So there's a lot of study around that right now, but we do have options to landfill, incinerate, or reactivate. None of those are in the state of California. We have to truck it outside of the state, but there are options.
And Patricia, given the subject of waste handling is sort of emerging in some of the federal legislation that's coming out, I believe the Federal PFAS Action Act, which I believe passed the House of Representatives earlier this year, one of its many points of emphasis is listing a specific PFAS, PFOA, as a hazardous substance under CERCLA. From where you sit, do you think that will have a meaningful impact on disposal options and or costs?
So what that will do is it will require generators to select a facility that is CERCLA approved. It does not automatically change your waste from non-hazardous to hazardous. It just means that you are required to use a CERCLA approved facility. Most of the options I've just laid out to you are CERCLA approved already, so you shouldn't see much change in cost or options. It's more of a classification. Scott, I know you can talk a bit more about the impact of CERCLA.
Yeah, I think that's spot on. It's not going to immediately designate it as a hazardous waste. I know that's everybody's concern. So yeah, designating it as a CERCLA waste does bring to it a certain, area of focus. But like Patricia said, it's going to go to places that are already potentially CERCLA approved to manage that waste. I know, like outside of California, there's PFAS is already designated as a hazardous waste. It doesn't mean that the residuals are hazardous. It means that there's specific reporting requirements to use AFFF if you're an airport, that you have to report it and you have to document its use. It just because it's classified under CERCLA, it doesn't mean it's a hazardous waste the way we have the connotation of hazardous waste.
Okay. So there's some emerging, buzz in the industry about, perhaps being able to get away from maybe some of these single-use resins and products that you're forced to dispose of every time, and come up with an idea of a regenerable product that can be kind of restored on site. Scott, we don't hear a lot about this technology and any sort of full-scale implementations of it that, at least on the surface, appear relevant to drinking water applications that we're most concerned with here in Orange County. But could you maybe just kind of tell us where you kind of see that regenerable resin, or are there similar technologies right now, and where you see it going?
In the States, where the big fit for it has absolutely nothing to do with drinking water at scale. It's really being focused as a remediation technology to, for source zones, say, at military bases or industrial facilities that have source zones that are contaminating groundwater. You can do that at, a couple hundred gallons a minute, and that's usually a decent size, remediation type system. At that scale, it seems to be more of an applicable technology to be able to regenerate. Patricia can get into a little bit more of the details, but it's a complicated process. utility owners don't want to be regenerating on site with the type of chemicals that have to be used. So, I think that right now it's a scale issue, and it's a complication issue, and that's why we don't really see it widely applied. You had mentioned what they're actually using, right?
Yeah, so our product can be regenerated. It's a methanol-based chemical reaction, not brewed for drinking water. It's highly flammable. If you are doing this process, you need to build an explosion-proof building to contain it. You also have a lot of waste. That becomes another issue to deal with. I'm talking about scale. Your Belinda's plant is 18,000 GPM. The amount of waste and process required for a plant to regenerate that amount of resin, it's just not feasible on a daily operating basis right now. And then the irony too is if you use this product, you need to have firefighting foam on site. And so you're basically keeping the problem going. So right now it's just not feasible. Also too, we found that it degrades the resin. So each time you regenerate, you lose some capacity. So it's the value and the payoff isn't quite there, in addition to the hazards.
Yeah, I'll add that there are drinking water systems with regenerable resin outside the U.S. and they were either attracted early in the process, and I'm not sure if they really kind of thought through everything, to be honest with you, or they're in very, very remote locations where it's, quite frankly, probably easier to regenerate on site than it is to get new resin there. So I think it's a site-specific application, but quite frankly, my personal opinion is I don't really see it ever in the short term being valuable at scale for what California is dealing with in terms of the volume of water that they're treating.
Okay. Kirk is the guy on stage who has to really execute these construction projects. What are some of the things that your partners in this project, so a design engineer like Scott or a treatment solutions provider like Patricia, what are some things that they can do for their role in the project that makes it ultimately easier and more efficient for you to execute the construction phase of these projects?
Well, I think nobody would say, I don't want a successful project. And nobody ever says that. But then we'll put out plans and specs that aren't completely thought out, and we run into problems. And so first off, I would say, make sure you take the time to make a spec that you really want to have built and that the homework's done. And secondly is to, when you're out in the field, you don't want to have confrontations, and if you don't have enough time in the schedule, then it forces the contractor to ask for time for every little thing every day, which causes conflict on the job site. And all that conflict, I think, hurts projects. So first off, just make sure you have a proper spec, your schedule is correct. Then third is, we are in a low bid dollar environment, and I would say that you could do a couple different things. You could do pre-qualification on contractors and have them have experience, and included in that could be conflict resolution, as like, are you guys going to court all the time? And if you are, then you probably don't want that contractor. And then have they done that type of work before? We do water tanks, and they'll have that kind of thing, and they'll say, well, I have a watertight manhole, and it's like that's going to be similar. So just to have specifications that require that the work is going to be done by someone that's actually done that kind of work before. Further, the reason why you'd want one that has is when you're setting these vessels, there's a lot of piping that all gets set together, and when you're if you set the vessels incorrectly, you're going to be inducing stresses into all your pipe, and then you're going to have leaks, and it's going to be a catastrophe later on down the road. And so having that experience to set them and make it so the project is good and just flows is great. There's a couple things that we like. On anchoring these, we like to do late pours, which means you leave basically a hole underneath each leg, and we set the vessels over there, we support it, and after all the piping's done and all the vessels are adjusted, then we'll pour the anchors into place. Now that may seem more expensive, but it's actually not, because you save all the problems that come from doing it incorrectly. And then the other thing I would say is having a little more flexibility after their tree piping, is to having some flex couplings in that area and expansions. So when we're then connecting to the piping going off the site, we can do make those adjustments. So in my view is, I think we all want a project, we're all going for the same end. And the better we can make the specifications and the whole team looking for that, the more successful your project will be.
Patricia, anything to add on that from your role working successfully with contractors?
I think the expansion joints and some of the stuff we take into consideration, especially like as an RFP comes out, we'll look through and reach out to the general contractor and say, hey, would you like to do it this way? Like add an expansion joint here, because this will make installation easier. You don't have to perfectly fit up everything. It gives you a little wiggle room. Having a lot of discussions early on to align and say, you know, here's ways to save money, here's ways to install it smoother, here's ways to service it easier later. Yeah, I think just being involved early on in the design process, talking about access. You know, once it's built, these guys have to operate and service it. So getting that input early on, are the driveways wide enough, you know, the grade smooth enough, things like that that are bigger picture than just, did I pick the right vessel and the right pipe? Like, how do I make my product easier for him to install and still have the most competitive price?
Scott, our just conversation today has been, you know, largely focused on drinking water treatment. You know, that's where a lot of the initial regulations have been aimed, where the initial impacts have been for these contaminants. Moving forward, what do you see as maybe additional types of sites or environmental media or just different applications where you see requiring treatment services that maybe aren't a primary focus today?
Yeah, interestingly enough, I mean, outside of the focus with the military and the DoD and, you know, the AFFF issue that really brought this to the forefront, the drinking water is really being driven by regulations, and we all know that they're state level, and we don't have any federal level regulations yet. But what you may not realize is that because of that, there's really no federal cleanup standards either. So really, I think where this is going is it's really moving out of drinking water and expanding to a number of different media. We're dealing a lot now on the municipal side with concerns with biosolids application, concerns with wastewater. You know, we're experiencing that in California with the phase 2 or phase 3 with, you know, looking at evaluating our wastewater and what the PFAS is in the wastewater. But then even getting out of the municipal space, largely there hasn't been a ton of focus on actual cleanup. So, you know, the PFAS remediation moving into the industrial space beyond the big players that we've all heard of, you know, like 3M and Parkersburg, West Virginia, there's a number of other aspects to that I think this is going to continue to evolve into that isn't just drinking water related.
Very good. I think we have some time left in the session for questions from the audience. So if anyone is interested in posing a question to our panel, please raise your hand, and I think we have some mics available.
Is there a social equity issue with California laws prohibiting the processing of contaminated waste within the state?
I'm not sure I understand the question. Can you rephrase it?
If we need to take resin and carbon out of state for processing, shouldn't California be dealing with this internally and not just shipping this problem to another state?
I would very much like to see that. I think with the environmental regulations, we're very limited on what we're able to get approved within the state. So unfortunately, I don't see it happening at this time. Yeah, I don't know. With the tight regulations here to get those types of facilities approved, it just doesn't seem likely to happen.
Thanks. This is probably more for Jason. I want to understand more of the risk of the PFAS. On one hand, let's say I drink a couple glasses of tap water. On the other hand, I fry a couple eggs a week in a Teflon pan, and if I get a pizza once a week in a pizza box, which one gives me more exposure? The couple glasses of tap water, or actually getting something that there's some PFAS in my pan or my box? Just to kind of get an idea.
Sure.
Is it orders of magnitude, one or the other?
Sure. Yeah, I think a lot of it depends, how much PFAS is in that glass of water, right? I think in the studies that have been done, in studies that don't have high levels of PFAS in their local tap water, those other exposures are more important to folks in terms of their body burden of that. Whereas I think when they've looked in more contaminated communities, let's say with a point source very nearby, right, that's contaminated local water supply, they do find elevated levels of PFAS in blood serum for people like that, and epidemiological studies showing increased incidence of certain diseases and cancers in those folks. When they're exposed to those elevated levels, you can see that. So I think it's all a matter of what that dose is in terms of what proportion of your body burden is being taken up by drinking water.
Could I just add to that, Jason, real quick? Just in case you're not aware, the values that are established, at the state or federal levels, assume that 80% of your body burden is coming from the pizza box and from breathing in, dust off the carpets that are treated. So only 20% of the body burden is assumed when they establish these values is coming from your drinking water.
Yeah, this is kind of a follow-up on each one of those. And PFAS is presented as a healthcare or a health risk, but it seems like there's been a real dearth of studies that have connected direct risk and exposure to PFAS to direct medical consequences. Can you expand on where we are in understanding any direct connection with PFAS and medical consequences?
Sure. Yeah, I think historically, some of the early standards for PFAS in drinking water and on other health levels were really based on laboratory studies, looking at the effects of PFAS on laboratory animals and extrapolating those to humans. But more and more we are seeing more human epidemiological studies being published which show that relationship between PFAS exposure and adverse health outcomes. The state's public health goal that I mentioned earlier for PFOA and for PFOS now are underpinned, and the state has drawn upon a recently published national epidemiological study looking at the occurrence of PFAS across a wide spectrum of the population, and from that inferred this very low risk level. So I would say that the science is moving towards, and more studies are now coming out that are finding a more direct correlation between exposure and health outcomes. And it seems like everyone that comes out, that threshold of exposure appears to be getting lower as more studies come out. But it's definitely an evolving part of the science. Any other question? Yeah, right here.
Hey, Jason, the St. Anna River is one of the major sources of PFAS into the groundwater basin, and we've known that for quite some time. And we've got all these nice plants taking it out for individual districts. What percentage of the inflow are we treating? And if we're not treating 100% of it, what's the long-term buildup of PFAS in our water supply, and how is that going to spread to every well in Orange County?
Right. Yeah, Director Swan, that's a complex question, and we are looking at the river as a source, as was mentioned, that is being investigated by the state, especially the discharges to it. I think we have another panel coming up here that's focused on the river that may be better positioned to address that question. But I will say that is an area we're beginning to look at more closely for the reasons you cite.
Do you have any idea what the percentage is that we're taking out in all these expensive?
Right. I do not. No, I do not.
So we haven't calculated that out.
We have not yet. No, we have not.
Okay.
So as we close today's session, I just wanted to first of all thank our panelists, and also just wanted to turn to the importance of addressing this PFAS issue legislatively as well. You know, there are a number of bills that have been introduced now that potentially put ratepayers at risk. So I just want to take this opportunity to share just 3 OCWD, Orange County Water District legislative priorities for PFAS, which really reflect the significance of this issue to us and our ratepayers. First, we really need to gain an exemption for water and wastewater agencies from any liability for PFAS cleanup. There's currently proposed federal legislation that could expose water agencies to this liability. And so as a water industry, we need to secure an exemption to that, which is very similar to the exemption that the nation's airports currently enjoy. Secondly, we want to ensure that Congress preserves the long-standing current law where EPA needs to do a cost-benefit analysis when establishing any enforceable drinking water standard. Eliminating that important step in the process really has the potential to burden ratepayers with really high costs of compliance that outstrip the associated public health benefits. And finally, as we heard earlier today, in just the water supply arena, specific to PFAS, we really need grant assistance for water and wastewater agencies to cope with this problem that really isn't of their own making, and to provide assistance for implementing pretreatment and source control programs to reduce the discharge of these compounds into our treatment systems. So there's a water district table at the entrance of the event here, and you can find copies of our federal priorities and related to PFAS and some template letters and resolutions that you could use to help support, advocate, and support these efforts for us. So with that, I thank you for your attention today. Please help me thank our panelists.